very large distance, very high mass, then Newton's law will not work. So what are the basic flaw? Newton's versus Einstein. Okay. So Newton's assumed gravity is instantaneous. You know that what is instantaneous. That means if sun disappear tomorrow at 7 a.m., that means Earth will also disappear at 7 a.m. That is Newton's idea. But that is not true. Anybody knows that if sun disappear tomorrow at 7 a.m., sun will not disappear, don't worry. Okay, but how long Earth will still move? Anybody has any idea?
8 minutes.
8 minutes. That means what is happening? Information is coming. So what information? That means gravity needs some information to come, and that information comes through a wave called gravitational wave. I'll show you the video. So that gravitational wave, the moment, suppose you drop a stone in a water, it creates a wave and it comes to the shore, takes some time. The same way, if sun disappear, that perturbation creates an waves in the, where it creates the wave? In the space and time, we say. Now, when we say waves in the space, we have already discussed what is space. Space is nothing, yes? So it is wave in the nothing. All other waves has an energy, you can see it, no? But if nothing moves, you cannot say, okay, nothing is going up and down. Then it is not nothing, it is something. But if there is something on the nothing, that will also go up and down. Like when the water waves happen, you can see the water wave also if you put some small floating thing, and then it will go up and down. Then you know that how the wave is going. So in same way, when the gravitational wave comes and hit Earth, something happens to the Earth also. Okay, that has been discovered and got Nobel Prize just a year before COVID. Okay, and that is called gravity wave. But the gravity wave is very tiny in the amplitude. Okay, so if sun disappear, the wave will be so tiny that when it passes to Earth, you cannot detect it. You need a much higher amplitude or much high energy collision, and that happens when two black holes come and they spin and they merge into it. It is said that when even two 30 to 40 solar mass black holes, which are enormous in number. So they saw that 1.3 billion light year later, two black holes once merged, and last millisecond before merging, the energy density is close to Big Bang. And that creates a huge gravitational wave, and gravitational wave is the wave of nothing, so it does not get stuck by anything. It can pass through you, pass through stars, pass through, because something can get stuck, but nothing you cannot, no? It can move. And that came and travel in the speed of light, as you said, it takes 8 minutes, no? And it passes through Earth. And in Louisiana, we have an interference. You are a physics student, so I can tell that in America's Louisiana, they have a 2-kilometer arm laser beam. Okay, so there is a interferometer here in the screen, and then what happens? Gravitational wave. So there is, I am not able to draw it fully, but what happens? They throw laser beam, it gets reflected and come here, and you know that if path difference is 0, then you get a constructive. So now what happens when gravity wave pass by? Suppose gravity wave pass by through this. It has two polarization. Okay, so one side gets squeezed and one side gets elongated. You know that. So if gravity wave pass by through this auditorium, one side will be squeezed and another. So that is the nature of the gravity wave. Like photon also has two polarization. No, the gravity wave is very similar to photon because both moves in the speed of light. What happens? What happens when the gravity wave pass by? One arm get elongated and one arm get squeezed. So then the path difference will change, and that will create a disturbance in the image. You know that the interference pattern totally depend on the path difference, and then they have the laser beam. But if the beam length, the tunnel length decreases, then laser beam length also. Because when space squeezed, everything in the space gets squeezed. You remember? Even the wavelength gets squeezed. That's why we have redshift elongation of the waves we talked about. The temperature of the cosmic microwave background was 3000 Kelvin, but now it is 2.3 Kelvin because wavelength is getting redshifted. Yeah. This they saw the blip in this. And it is not forever, it just pass by, that's it. Because it is not a continuous wave like fossil radiation. It is like the black hole merger happened and then the black hole merged. After that there is no wave. Getting it? So that moment wave come and then and that gets the Nobel Prize. But Einstein in his pure mathematics predicted that if my theory is right, one day they will discover the gravitational wave, and that got discovered. And then Einstein also said, if my theory is right, there will be a supermassive black hole in the center of our galaxy, and they also discovered Roger Penrose and the two more got the Nobel Prize. No, I show you the picture. Supermassive is hidden there. 10 to the power 6 solar mass black hole, huge. I told you in the beginning, if you squeeze sun into a black hole, how much will be the distance? Today I told in the beginning, few kilometers, 10 to 15 kilometers. But 10 to the power 6 solar mass means it will be 10 to the power 6, 7 kilometers. Getting it? That much is our center of galaxy. But compared to size of the galaxy, 10 to the power 6 is nothing kilometer. So it is almost like a small thing is rotating 500 billions of stars. So now all this theory is based on Einstein's gear. Otherwise you will never get black hole, gravity wave, everything in Newton's law. Okay. So first is Newton's assumed gravity is instantaneous, which is wrong. Because that's why you still need 8 minutes to communicate from, even if sun disappear, you can still think about your life for another 8 minutes. Okay, getting it? You can worry, you can think already sun is gone. Okay, but 8 minutes you don't see it. Okay, next, Newton assumed empty space is nothing and does not participate in the game or play of matter. Newton assumed that empty space is like a drama stage and particle is just moved by the equation of motion. But once I show you the video, that is Einstein's miracle, you will see that gravity itself is not a force. It actually comes from the bending and dance of the empty space. Okay, it will be very clear from the video. We know that the universe is expanding in all directions, so it is property of the space itself. One can never get expansion of the space from Newton's formalism because space is just a spectator. Because for Newton, space is really nothing. But here, space is expanding. You can never get it from Newton's law. And then much more, Einstein's mathematics showed that gravity depends on pressure. So I draw this, you will be amazed that you will never knew that before. Suppose I tell you two massive body. One is M1 and then is M2. Now the force of gravity is G M1 M2 by R square. Okay? M1 M2 by R square. This is R. Now it never tells that what this mass is made up of. In Newton's law, they never say that they just need the center of mass, isn't it? Einstein says no. Even if this mass are same, suppose this is made up of iron, both, and you get another same mass, M1 and M2, same mass, I didn't draw rightly, and one is made up of gas, which has pressure. Gas has pressure, no? Iron does not have pressure. This force will be different. How many of you didn't know that? Even if the mass is the same, only mass is not enough. So now onwards, you don't tell your nephews when they are studying in class 10, hey, it is wrong. No, you don't tell them it is wrong, but it is true that if things has different pressure, the state of matter also matters. Getting it? And today we will show that. That is Einstein's magic. And whole dark energy, which I have been talking about, has been measured because it has a different pressure, negative pressure. And it reacts to the space in a different way than any other thing will do. So if Newton will never get dark energy because the pressure does not even matter for gravitation. Getting it? So now, where is my... So now let us, it is on now. Yes. So now watch this. This is from Brian Dean. who is my PhD advisor, and then I moved to New York University. He was 3 years my PhD advisor. So how from Newton to Einstein? Whether Einstein was a
Before
cloud.
Einstein, the quest for unification began with the most famous accident in the history of science.
As the story goes, one day in 1665, a young man was sitting under a tree when all of a sudden he saw an apple fall from above. And with the fall of that apple, Isaac Newton revolutionized our picture of the universe.
In an audacious proposal for his time, Newton proclaimed that the force pulling apples to the ground and the force keeping the moon in orbit around the Earth were actually one and the same.
Newton said that celestial and terrestrial are the same.
Newton unified the heavens.
The force which governs planets is the
and
same.
Earth
That force which
in
governs the
a
atom
single
force.
theory.
That is the unification Newton did. Through this D, Newton's
After
constant.
nearly 10 years of racking his brain,
Then Einstein
he
came
found
in
the
picture.
answer in a new kind of unification.
Einstein came to think of the three dimensions of space and the single dimension of time as bound together in a single fabric of space-time.
So Einstein somehow came to know that space is not nothing. Okay. He somehow saw in intuition that space can bend when you put mass in the space. And now you know, suppose sun is here, space is bent here, then if you have seen, no, in the Mela, if some space is bent, then if you put a marble and if you give an initial velocity, marble will do and then come in the center. But as it has friction, that's why it come in the center. But if there is no friction, it will continue doing like that. In space there is no friction, that's why tiny friction is there. Even Earth one day will come, but that takes billions of years. Okay, so that's why it continue. So it is not gravity. Origin of gravity is so different than other forces. Other forces are instantaneous, but gravity is nothing but the geometrical disturbances or bending of the space and time that exhibit to you as if gravity is there. Getting it? And perhaps that is the reason this gravity and all other three forces are a little bit separate. Other three forces are actually unified. Einstein wrote a book called Unified Theory of Forces. Weak force, strong force and electromagnetic force was the same force just after Big Bang. And as the universe cools down, they bifurcate and they become three forces. But nobody can unify yet gravity to it. Because gravity, when you want to unify it with the other forces, it gives rise to all 1 by 0 term. And that's why gravity and quantum mechanics don't talk to each other. All other forces are actually done by quantum mechanics. You can actually derive that why, when one electron and two electron are here, why the force is E square by R square. You can derive mathematically from Feynman diagram, okay, by quantum mechanics. But you cannot do it for gravity, it is very hard, okay. And that's why when you want to come to very small distance, that is the problem, because small distance means what mechanics? Quantum mechanics. That is in the beginning of the universe, the distance is less than even femtocentimeter, okay, after Big Bang. And gravity is when applicable when masses are huge, like sun or galaxy, black hole. And that time mass is enormous in the beginning. Whole mass is concentrated inside. So you need both gravity as well as and quantum mechanics. Then you apply, they blow up. Because you cannot do both together. That's why gravity is not married with quantum mechanics, okay? It is not talking. But every force in nature is quantized by quantum mechanics. So that's why the string theory came in picture. Okay?
But another beauty is that though Einstein didn't believe much in quantum mechanics, his questions and the theories were actually, they gave Bohr and all many scientists to come up with any quantum mechanical theory.
Exactly. Einstein himself said that God doesn't play dice. But quantum mechanics is all dice, no, I just did. Because you don't know what will happen. All dice. Because you measure the same electron, first time you find in first orbit, second time second orbit, it's all probability. Anything can happen. That is why it is called the collapse of the hypothesis. In fact, that is called EPR paradox. Einstein says whether a cat is dead or alive, you cannot say it before. If you open the box, then only you can say it is dead or that means you cannot predict, because in quantum mechanics sometimes you open cat is alive, sometimes you open cat is dead. So by observing you are making the cat dead or alive. Getting it? Because there is no reality when you don't observe. Because wave function can collapse in 1s, wave function can collapse in 2s, that is the thing. But Einstein didn't believe it. Still, maybe that's why Einstein didn't, still they cannot quantize Einstein's theory, because he had issue with that. Okay, anyway, so now let's play it and you will see that what is happening.
It was his hope that by understanding the geometry of this four-dimensional fabric of space-time, that he could simply talk about things moving along surfaces in this space-time fabric.
Like the surface of a trampoline, this unified fabric is warped and stretched by heavy objects like
so moon
planets
is
and
rotating
stars.
Just because the earth is curving the space-time.
And it's this warping or curving of space-time that creates what we feel as gravity.
A planet like the Earth is kept in orbit not because the sun reaches out and instantaneously grabs hold of it, as in Newton's theory, but simply because it follows curves in the spatial fabric caused by the sun's presence. So, with this new understanding of gravity, let's rerun the cosmic catastrophe. Let's see what happens now if the sun disappears.
So suppose sun disappear, tomorrow 7
The
a.m.
gravitational disturbance
This is the gravity wave.
will form a wave that travels across the spatial fabric in much the same way that a pebble dropped
Still
into
8
a
minutes,
pond
Earth
makes
rotates.
ripples that travel across the surface of the water. So
And when it
we
does
don't
this,
feel a change in
then
our
Earth
orbit
goes
around the
tangentially
sun
into the empty space.
until this wave reached the Earth. What's more, Einstein calculated that these ripples of gravity travel at exactly the speed of light.
And so, with this new approach, Einstein resolved the conflict with Newton over how fast gravity travels. And more than that, Einstein gave the world a new picture for what the force of gravity actually is. Its warps and curves in the fabric of space and time.
Einstein called this new picture of gravity general relativity. And within a few short years, out.
So it looks very nice in video, but once you want to learn GR, general relativity, you have to do all tensor calculus, because the tensor, what it does, it calculates the curvature, because you have to ultimately predict, you have to quantify. Okay, so Einstein's GR is basically what one side is geometry and another side is the mass or the energy you put. So one side is the stress energy tensor, because you know the pressure, mass, everything enters, another side is the geometry. That geometry, even when Einstein discovered this GR, inside him as intuitively the space, but he did not know the mathematics. Then he went to Euler, you know Euler's equation? He went to Euler and said, teach me how to calculate the curvature of space-time, and Euler said, okay, see. Then, so that's why no mathematics can create discovery. Discovery always happens inside you. And then mathematics is the language where you speak it. Getting it? So Einstein's already got it, but he didn't know how to express it. That's why he went to Euler, please teach me, and then Euler taught him, and then he wrote these complicated equations, left side. But nowadays, even I teach it in IIC, I taught 2 years consecutive in Institute of Science, GR. Nowadays, people are very smart. Nowadays, Mathematica software has a code, so they don't have to calculate all the tensors. They can put it and say, like, show me the curvature. Curvature is a tensor, okay, 4 by 4, cross 4, 6, 4, 10. So it has 16 terms. So you get 16 equations. Okay, you have to solve them, and then finally you get your thing. So I'll show a little bit. I'll show you that what it is. Okay. So now you got a basic idea that my teacher in IIT Kanpur, he told me in layman's language what is Newton's law and what is general relativity. He said that, okay, Subinoy, you are from Calcutta, there are old trams, small tram lines are there. So one engineer asked a student, so from where every point in the tram line you calculate the net force and tell where the tram will go. And that guy did a computer simulation, every point he said tram will come like that, bend and go like that and then go. I can see every point the force is going like that. And then the same guy asked a rickshaw driver that where the tram will go. They're like, wherever the tram will go according to that. He doesn't need to calculate all the forces. So Newton's thing is so much calculation, but Einstein said how the space curved thing will go. It is like a tram line, okay? But for Newton did not see that space as a tram line. So Newton saw that every point is a force, so he had to calculate. But Einstein, that's why it's a much more generic idea. He just calculates the bending of the space and it tells how. And from there, much more secret, the black hole came out from Einstein's theory. And I already told you, gravity wave and many things, okay? So now, how Einstein discovered general relativity? Actually in an elevator lift. So that's why he is genius. By the way, Einstein was a clerk. He was not a PhD student. He has interest in physics, but then that's why you never know what will come through you. Getting it? Okay. So then here is the idea. See, you have done it in class 12 or even BSc first or second year, that an accelerated frame of reference is experience an extra force than a frame of reference which is moving in a simple plane, non-accelerating plane. You remember that? If you accelerate, then you get an extra force. Yes or no? That's why when the car turned, why you get pushed? Because when you are turning, your velocity is changing. Even if you are going in the same speed, but the velocity direction is, that's why you are getting an acceleration. No, that's why car get moved. So the moment you move from a smooth velocity to an acceleration, you experience a force. And then one day Einstein was in a normal lift, and that time somehow the power cut happened or something happened, lift did a free fall. And then what was the force?
Gravitational.
Zero. Because he was experiencing a thrust on his leg when lift, but the moment lift started doing free fall, the force on his body is zero. Then he said, come on, I was experiencing gravity, but the moment lift started accelerating, lift free fall means it is accelerating in a g, no? The moment it started accelerating, my gravity is gone. Yes? He said that means, is the reverse true? That I don't have gravity but I accelerate and I create gravity, because if a acceleration can remove gravity, then some different kind of acceleration can produce gravity also, isn't it? Now I tell you how he got this idea is very interesting. That what is the difference between, if you plot h versus t, just a distance versus time for a smooth velocity and for an acceleration. What is the basic difference? For smooth velocity, x versus t will be how it looks? xt versus t. How it look? Straight line. The slope depends on what is the velocity. Yes? The slope depends, but it is always a straight line. Now in acceleration, it is never a straight line, it is a curve. So space and time is curved during acceleration. That was the clue in Einstein. Acceleration means he saw in the geometry. What does it mean, acceleration? Because he thought acceleration can create gravity, and acceleration means curved space, time. That is exactly you saw in the video. Curved space, time can create gravity. So that is genius. He did free fall and he discovered the the general theory of gravity. Rest, mathematics, tensor, everything. So is that point clear? That acceleration means you will always be a curved line. You can never get a straight line when you are accelerating, is it? That's it. And space-time is curved when you are putting sun or anything. So he basically needed space-time curve for gravity, and that's why you get gravity. Flat space-time, you don't get gravity because there is no mass. Clear? So this is the idea that how a mathematics of force becomes just a geometry. Okay? And for Einstein's equations are nothing but g mu nu, which is basically the curvature, which he learned from Euler, and 8 pi g by c square T mu nu, and T mu nu contained rho, and I told you pressure also. It's a tensor. You have heard about tensor, no? That's why the pressure enters into curvature. That's why how dark energy curves the space-time will not be the dark matter how it curves the space-time. And space-time curvature is nothing but, that you know a little bit later or later when you do course. Curvature is nothing but the acceleration, because you see, curvature is nothing but the acceleration connected. So this is the philosophy of GR, which I taught in 6 months in IIA Bengaluru, did it in 6 minutes in here. But when you do the exact mathematics, it's a lot of thing. So now, this part I did. Now I will do little bit. Before that, I go into little bit thing. And this is the equation. So once you apply this equation for universe, okay, this g mu nu is the curvature of the space-time. It carries the metric. You know what is metric? The distance. Because curvature means what? What is the distance? If you fly a plane from Bangalore to New York, the path will be curved. But if you can penetrate through Earth, it will be a straight line. Because the surface of the Earth is curved. That means the metric is different than the Cartesian metric, isn't it? It is not the distance plane travel, is not the x1 minus x2 square plus, or that will be the distance when a bullet goes from Bangalore to or Mysore to through the Earth. That is the straight line, x1 minus a. But on the curved surface, the metric is different. That means if you know how the measurement between two distance are varying, that actually tells you how curved it is, isn't it? That's why the metric enters here. And the metric of the space-time, I did not tell you totally, but I gave you a hint that you all know little bit of special relativity. And what is the special relativity metric? Anybody remember? So ds square, first of all, Cartesian metric is this: dxi square plus dy square plus dz square. I told you. Now, if you bring special theory of relativity, you know that. So time and space.
It will be -1, 1, 1, 1.
1. But there is other convention also. They take here 1, here minus. Both are okay. Okay. Now, I told you for cosmology, you have to multiply here by 80 square, because this distance is not the distance, because space is expanding. So this is the metric for cosmology, and C generally we put it in natural unit 1. So the metric become -1 A, because there is a multiplication 80. Rest is 0. Okay. So once you do write down the equation, you see the metric is entering in the left hand side. Derivative of the metric. There are 2 equations out of 16 equations, only 2 are independent. One is the A dot dot by A square, because the metric, when you write down the Einstein's equation G mu nu that Euler taught Einstein, it involves lot of derivative of the metric. So that's why you are getting a derivative term here. And double derivative. So first derivative term, this is called Hubble equation, Friedmann equation. A dot by A dot is the velocity of the space. So velocity square depends on, forget about this term, these are all negligible terms, okay? Depends on the rho. Rho is the energy density. That means how much energy you put depends on how much velocity of the space you get. That's why we needed dark energy. But more than that, the acceleration of the space depends on minus rho plus 3p. P is the pressure of the fluid, we put it in the universe, and rho of the universe. Now, the supernova project measured that the universe is accelerating. That means A dot by atom is positive or negative? Is accelerating, going faster. That means positive. But here there is a minus term. That means rho plus Cp has to be negative. That means P by rho has to be less than minus 1/3. That means rho cannot be negative because rho is energy. So P by rho less than minus 1/3, that means pressure is negative. There is never ever we have encountered negative pressure in the history of physics. Positive pressure means what? In this room, suppose there is gas in a balloon. If you puncture the balloon, gas will do what? Come out. That means it has a positive pressure. In kinetic theory of gases, you have always seen the pressure of gas is positive. 1/3 term comes, no? Cavity. So positive. Here, you need a negative pressure. That means, if dark energy is covered in a room and you open the window, it will not go out. It want to compress. But if you want to compress dark energy, it will not resist. It will say like, okay, come, because it has negative pressure. Positive pressure, if you want to compress, you have to do work done. Getting it? PdV. Getting it? Here negative. So no gaseous system, no fluid system has ever got negative pressure. But you need negative pressure for acceleration to be. That's why it is the most mysterious thing. No particle physics can give you negative pressure. Every system you see, it always has kinetic theory and it always gives positive. But this is how it is there. So it's very interesting. Dark energy wants to contract, but because of that, universe expand and accelerate. Many people in the interview, YouTube will see dark energy is a repelling fluid. It's wrong. Dark energy is an attractive fluid, but once you put it in Einstein's equation, it repels the space-time. Getting it? I am working on it 20 years, but I still don't know that what actually happens. Because mathematically you can say, but what is happening, one thing is attracting in this room and the space is repelling. You know, there is something in physics you cannot sense it through your 5 senses, is not possible. Okay? Mathematics is guideline, but before that Einstein has to do this magic. Okay? So now I will tell you to do little mathematics. That is very simple. Okay? So now, before that, anybody has any question? Because madam was telling you have a lot of questions, you can ask now before I go to little mathematics. Okay? Any question, not mathematics, stupid, good questions. You say, okay. Anybody? What happened to the questions? From last talk also. Then please tell. Don't get shy, no? Who has question? If you are shy, you can tell madam, she can tell me the question, okay? No, you have to ask question, no, otherwise you'll never.
Yeah, you can proceed, I guess. You can. Okay, they have this question. So in previous talk, you had written the expressions, right? You told about the ionization energy and all. So you said that there will be ionization, so therefore there will be ions. As a result, and that 13.6 temperature.
Electron volt.
So they are telling when atoms themselves are not there. So how can you speak about the ionization energy, and what about the electrons?
No, that time the atoms are there. Not atoms are there, but the nucleus is there, and electrons are there, and photons are there. That's why we can see. It is not that nothing is happening. So you have nucleus, neutron, proton, like that. So it is plus charge. Yes, there are many nucleus. I am now writing as nucleus as plus. Neutron, proton. They have combined. Now there is electron floating, and there is proton floating. Now once in a while, it's a random process. Electron will come and combine. So there are atoms forming, but immediately a photon comes and knocks them out. So it is not that they are not forming at all. So atom is forming, but that's why the photon is doing a random walk. You know, when a drunk person in the night, he thinks he is walking very fast, but he is going nowhere. Okay? So like that, the photon is thinking that it is going, because it cannot be stopped. It is always moving in the velocity of light, but it is always with zigzag. It goes here, come here, because it is colliding with, ionizing with, wherever there is a full atom, it goes and get knocked out. Then it gets recoiled, all these things. So that's why photon cannot come. The moment hydrogen, then there is no more interaction, then photon comes freely to us, and that's what we see then today after 14 billion years as cosmic microwave background. Getting it? So it is there, that atom is forming and immediately getting ionized.
No, but it can also be, is it like, is it the exact nucleus which is positively charged, or just like, since as you mentioned it as a plasma, so which is a mixture of all sort of negative and positive charges. So that maybe the protons.
No, here maybe proton.
And protons are existing by themselves, may not be forming the nucleus.
No, that time in 13.6 electron volt nearby, before proton and neutron has already combined. Before, if you go much earlier, that time neutron and proton, they are called QCD plasma. There are different plasma. That time neutrons and protons are above. And if you go even before, then you will see the neutrons is inside, what is there? Quark. The quarks are also different. They are called quark-gluon plasma. So different plasmas are there as the temperature drops. Okay. Getting it? Now, no more questions? Done? Any more? Otherwise, we will ask you to do. Yes.
I have one simple, since you are also a popular science person, this question came to your mind after this ionic discussion. Today, 2 years back, I went to Bharat Hospital, the cancer hospital. 20% is the increase of cancer. And today we are using RO water. If you go for ionic water, microcluster, this can be totally prevented. There's an implication, you see, 14 billion years, something happened. Today, Mysore has got at home 6 to 7 lakh RO plants. And everybody carries, everybody carries a water bottle. It's a symbol of cancer. You see how relevant it is. I was very much fascinated.
Yeah.
Thank you, Raj.
So now I will ask you to do something. Okay. So this is the Friedman equation. Let's do something with the. You can do simple integrations and calculation, and you will find that how. So our metric is d square is minus c square dt square plus a square t sum of dxi square. Okay. Now at if you can solve, you know that how fast universe is expanding, right? At is the scale factor. Now, first Friedman equation is a dot by a square is 8 by g by 3 times rho total. So now, if I tell you that how this rho, we know that if I tell you it is, say it is only matter. Now matter, you tell me that if I have a box, I have some rho. Rho means what? Rho means n by v, number of particles times mass. Mass is basically mc square, c I am omitting, by v. This is basically rho. Now if I tell you that the box become, universe expanding, box become 2 times in every direction. That means volume becomes 8 times. So how much will be the new rho? You can do it. It's very easy. Number of particles is constant. So suppose this is, initially I have rho naught. Rho naught is this one. So now my volume has become 8. So that means rho will be how much?
Reduced by 8.
So rho will be rho naught divided by 8. 8 is basically nothing but a cube. Scale factor. Scale factor is become 2 times rho, because scale factor is stretching the universe. So rho becomes rho naught by a cube. Now you do the another, this I ask in IIA PhD entrance. So now I have the same thing, same volume, n number of, not particle but photon, and volume v, initial energy rho, they are all photon inside. And now it has become again 8v. So what will be the rho compared to rho naught? What will be the Is it will be the same, 1 by a cube, rho naught by a cube, or different? See, photon has something. Photon is both particle as well as wave. So when every direction is stretching by 2 times, then the wavelength will be also stretched 2 times. So there are 2 dilution factor. One is the number of particles goes by 1 by AQ because volume has become 8 times V. Also, each particle's energy, before it was, for other case it was just m, but for photon it is not mc square, for photon it is hc by lambda, and lambda has become 2 lambda. So each photon's energy has become another 1 by 2. So here you will get actually rho naught by a to the power 4. Getting it? So as the universe expands, whose energy falls fast, matter or radiation? Photon is radiation. So that's why if you draw the universe's energy, because universe in early universe has both matter, both photon, everything, right? If you draw, I am drawing rho I, so in log scale, log A, scale factor. Scale factor higher means today, scale factor small means early time, when universe is. Then you get -3 slope for matter, because 1 by AQ, if you plot in log scale, you get -3 slope. You getting it? And for radiation, it will be here or it will be here. Sharper fall or flatter. I am plotting rho naught by A cube versus rho naught by a to the power 4. Rho naught by A cube, you already show that it is for matter. For radiation, rho naught by A cube. How it will look?
Fast, very fast.
It will be like this. That's why today you don't see universe has radiation content. Only 4% visible matter, 26% dark matter and 70% dark energy. See, because universe has, the radiation has gone down. Now, for dark energy, it is constant. It does not change. So today universe is dark energy dominated, that is called rho lambda or cosmological constant. This is matter, so this is 70%. This is 30%, 26%. Photon is nothing. It is actually 10 to the power -5%. And the visible matter I am not doing, it is like a matter, it is 4%. So now mathematically you know that what is the history of our universe. So I will show you the plot. That is what people learn in the graduate school of cosmology. That is called the history of universe. This is what it is. You see? This is the dark energy, it does not change. This is the radiation, matter. Today we are here. So dark energy is a little bit higher, matter is here. It is in log scale, so radiation is much lower. It is not exact plot. So now you tell me, if you go back early universe, which one dominate? This is first. The green. Green is what? Radiation. That's why universe is only radiation dominated. So that's why we call it hot plasma, relativistic. Getting it? So that's why radiation dominated green, then matter dominated red, then dark energy dominated blue. Later we don't know. Now the video which I shown by Professor Brian Greene, people believe that, as I say, if future astronomers comes, they will see there is nothing because galaxy has gone apart. But recently, 3 months back, there is a instrument, is called Dark Energy Spectroscopy Survey, DESI. It has found a hint that dark energy strength is decaying. That means universe is accelerating now, but it will cool down. It may slow down, and if it is true, then we might end up in a cyclic universe. Means universe, like someone is accelerating in the car, universe is going apart from each other, then it slow down and again contract. If it finds another March beginning, it is releasing its second data set. Already if you search in YouTube, it is a big news that whether dark energy is vanishing, okay, and or evaporating. And if it is true, then universe will again may contract back. But if it is not true, then ultimately everything will go away from each other. Okay, and even Milky Way will also break down. Because if the expansion is so much, even there is a paper in PRL, at suppose 10 billion years later, expansion will be so much, even proton cannot hold the electron. So there will be no atom, there will be nothingness. Everything will go away from each other. All quark will go away. So you, as you like, we are in the same room now, and then after the lecture you will all go back to your home. So exactly, we are meeting in this universe for some time, and we will go back after billion of years. There will be nothing. So this is a meeting place. No, not here, the universe. Okay. Getting it? So this you do, and now one more. Then how much time we have? We are done pretty much.
Yes.
10 minutes. So I'll do another more little problem solving, and then we are done. So you did this. Now this one we have to do little bit differential integration, just simple, like, because till now I have not solved for AT. I have shown you the radiation dominated universe, matter dominated universe, and dark energy dominated universe. That is what exactly you need to do first half month or 2 months or 1 month of your cosmology lecture. People find out from Einstein's equation, solve the Friedman equation, and do this. Then you know that universe was radiation, then matter, and today dark energy. Now I have the second Friedman equation, and you tell me it's very easy to solve. No, first Friedman equation only. So A dot by A square is 8 by G by 3 rho, and rho we use it for matter dominated universe. We only put matter because the value is very high, log scale. Or for radiation dominated universe we only use radiation, or dark energy we only do dark energy. Now I tell you, suppose it is radiation matter dominated universe, then it is basically rho naught by A cube, right? Can you solve A as a function of time from this equation? It's a simple differential equation. No? A dot means dA dt. Okay? Can you tell me what is AT as a function of t? Then you know that how fast universe is AT, because AT is the scale factor. So I derived this, now I put it in there. So it's a simple equation. You do it 1 minute. Whomever get fast, tell me. You have to bring dA one side, dA and all the A, and dt one side, then integrate. I don't want the exact number, I just want the form. So constant term you can ignore. How much? Huh? Is going? At least in whole talk I don't just speak, you do little bit, okay, mathematics. Okay, that is also needed. Don't get afraid if you are right or wrong, just tell if you have got. You got? Huh?
Rho naught by A dot square.
Nah, rho naught by A dot square. No, A dot, A as a function of time. So you have to take dA by dt square root, because integral is not that. You have to, anybody doing it? Otherwise I'll tell. It's very easy. First take the square root. A dot square is this. So this is square root here. This is square root here. Now A dot is dA by dt divided by A is proportional to A to the power 3 by 2. Right? Square root 1 by e to the power 3 by 2. Now you do it. dA and 1 by A here. If you bring A this side, A to the power 3 by 2, and this side will be just dt. Now if you integrate, how much you will get? This is A to the power 3 by 2, then it will be like dA times square root of A. This part is equal to dt. I have done everything. Now you do last part. How much it is? dA times square root of A. If you integrate and dt here, some constant here, C1. Then what is A as a function of? huh? How much is integral of root a? Let's do it. A to the power 3 by 2 and proportional to some other constant, say alpha, and how much is dt? Integral t. So a goes as
T power 2 by 3.
t power 2 by 3. Why you are not telling? It is class 12. Okay. So you see, AT goes as in matter dominated universe t to the power 2 by 3. Your homework in radiation dominated universe, it was actually going slower, t to the power half. You do the same thing, but instead of a cube, you have to use a to the power 4. You get the same thing. Now you do the final one. For dark energy, I showed that the right hand side does not depend on any time or a or anything. A dot square is dark energy density is constant. I saw the straight line, no? Straight line. So it is constant. So now in this one you should do how a goes. Do it. A dot by a square is constant. How a goes. How a as a function of time is a constant. So a t, you tell me who get it first. So a dot by a is what? Square root if you take. A dot by a is also constant. Then do the same thing, integral. What you are getting a? E to the power t. Good. Finally, I didn't have to do it. E to the power some constant time t. So it's an exponential. So which one is faster? Dark energy time expansion or radiation or matter? Radiation or matter? What was the solution you got? T to the power? T to the power 2 by 3 for matter. For radiation, T to the power half. And now for dark energy, exponential. Which one is faster? Exponential is much faster. That's why when you put dark energy, universe expands much. AT goes much faster. Got it? At least some mathematics you will do. Okay? These are graduate level course. So that's it. So from there, cosmology you take from there. You put it in simulation and all these things. I showed the simulation, no, how filamental. That we write code, and all, of course there are a lot of things. You have to know thermodynamics, you have to know Boltzmann equation, all these things. Okay, but that's what people do. They try to produce the galaxy starting from Big Bang. From there is nothing. Getting it? But we still don't know what is dark energy. We don't know what is dark matter. We don't know what happened at t is equal to 0, and we don't know what is the fate of the universe. So all these things are unknown. Okay, that much for today. They have asked little questions also. Yeah.